Okay, so in this chapter on bonding, we're going to take a few minutes to talk about something called bond energy. So we'll talk a whole lot more about this when we get to thermodynamics in 162. But what you need to know for this quarter is about the bond energy, the overall what's called enthalpy. Enthalpy is represented with this delta H, change in enthalpy. And it's essentially the heat of a chemical reaction, heat being given off or heat being absorbed. So there's two types of chemical reactions. There's called endothermic reactions and exothermic reactions. So when a bond is forming, this is an exothermic reaction. This means that when a bond forms, it gives off heat or energy. And the sign of this reaction, the delta H, is going to be a negative number for an exothermic reaction. Exothermic reactions are when bonds are forming. The other type of reaction is when bonds are breaking. This is called an endothermic reaction. Endothermic reactions require heat or absorb heat. Heat is a form of energy. Endothermic reactions have a positive delta H or a positive change in enthalpy. So the way that we're going to determine the overall change in enthalpy for a reaction is this equation up here, which looks a little bit scary, but I'm going to walk you through it. Delta H of the reaction, so the energy change for the reaction, is always products minus reactants, final minus initial. So essentially what it is it's the sum of the number of moles of the enthalpy change of the products minus the sum of the number of moles of the enthalpy change of the reactants. So when you have a chemical equation, products are on the left, on the right, reactants are on the right. It's always final minus initial to get the overall change. So this is the equation that we're going to use. And this is the information that we have. So you're going to do an example of this in your lab. You'll probably see some questions about this on your SmartWorks homework. Okay, so you would be given the overall enthalpy changes of different types of bonds. So let's just see an example here. Okay, so let's say hydrogen and chlorine react to form 2 moles of hydrogen chloride. So hydrogen is H2, chlorine is Cl2, form 2 moles of HCl. So later in the quarter, we'll learn about writing formulas like this. That's not something you're required to do at this point. Okay, so you would be given the information about how much energy is in each of these bonds. So a hydrogen-hydrogen single bond is 436 kilojoules per mole. This would be given to you in a table. A chlorine-chlorine single bond would be 242 kilojoules per mole. Kilojoules is a unit of energy. And then a hydrogen-chlorine single bond would be 431 kilojoules per mole. So this table is given to you. There's no way for you to, you're not calculating this, but you're going to use this to determine what's the overall energy change of this reaction. So when you have a chemical reaction like this, these over here on the left-hand side, these are the reactants. Over here on the left-hand side in the reactants, these, I should have done that in this color, reactants. These reactants, these bonds are breaking. Over here in the products, these bonds are forming. And these are products. Reactants, products. Okay, so we're going to write our little equation up here. It's the products minus the reactants. So another way to write this is the delta H of the reaction is the energy of the breaking bonds minus the energy of the bonds that you're making. So it's the breaking bonds minus the making bonds. I said this backwards. It's the bonds that you're making, sorry, minus the energy of the bonds that are breaking. It's products minus reactants. It's the energy of the change of the reaction. Okay, so delta H of the reaction, the energy of the bonds that you're making. So here I have 2 times, because I have 2 moles of it, I have 2 of these HCl bonds that are being made. And remember, bonds that are forming are negative. So I'm going to say delta H of the reaction equals 2 times negative 431 kilojoules per mole. So these are the bonds that are forming. So then the bonds that are breaking, I have 1 mole of the hydrogen, 436 kilojoules per mole, plus 1 mole of the chlorine, 242, whoops, I forgot a 6 there, kilojoules per mole. So what's happening here is this is the energy of the bonds that you're making, and this is the energy of the bonds that are breaking. It's products minus reactants. Again, you're given this information here. So I'm just going to plug this into the calculator. 2 times negative 431 is negative 862 kilojoules per mole minus 1 times 436 plus 1 times 242, whoops, is 678 kilojoules per mole. So I have negative 862 minus 678 and I get negative 1,540. So these moles should be gone, right? Because this is 2 moles, this is 1 mole, this is 1 mole. So the moles will cancel. So negative 1,540 kilojoules is my final answer. That is the overall change in this reaction. Enthalpy change in this reaction. Energy that is given off from bonds forming, energy that is required from bonds breaking. So there will be a lab that you will do where you will use this, and you will be given a chart of all of the bond energies. Bond energies are different if you have a single bond versus a double bond, things like that. So you'd have to be provided that information, which you always would be, or you'd be given access to your textbook or a table or something where you could look it up. So this is how we calculate bond energies in chemical reactions.